In this video, I'm going to show you how to use the quotient rule to differentiate functions that take the form of a fraction. So the quotient rule tells us how to take the derivative of a quotient of functions, say f of x, some numerator function, divided by g of x, some denominator function. And the quotient rule tells us that the following is the result. The result is still a fraction, and the numerator of this fraction is kind of like the product rule. We have derivative of the first function, meaning the numerator function, f of x, that times g of x, and then we also have a term where g of x is differentiated. But instead of a plus, this is a minus. And that's very important to remember. Otherwise, if you put a plus, then you'll get the derivative wrong. So always remember that with the quotient rule, the numerator is a difference of terms, not a sum of terms. And also because of that, because it's a difference of terms, the order of the terms matters. The first term in the difference has to include the derivative of the numerator. So that minus the second term, which includes the derivative of the denominator. It's really easy to make a mistake by accidentally flipping it around, so don't do that. Remember that the derivative of the numerator always comes first. Alright, so this might seem kind of intimidating. This is only one part of the result in the numerator, but thankfully, the denominator is a lot easier. It's just that same denominator function, g of x, but squared. Alright, so now that we know the quotient rule, let's go ahead and apply it to take some derivatives. First of all, we want to compute the derivative of this fraction here, x squared divided by x plus 1. So x squared, that's the numerator here. That'll take the role of the function f, and x plus 1 is the denominator there. And that'll take the role of the function g in the quotient rule. So applying the quotient rule, the result is another fraction. In the numerator, we have the derivative of the numerator first, derivative of x squared, that multiplied by the denominator, x plus 1, and then minus the numerator, x squared, multiplied by the derivative of the denominator, x plus 1. And that's all over the denominator squared. So x plus 1, the quantity squared. Alright, so let's go ahead and compute this. Derivative of x squared, just bring down the exponent 2, so 2 times x, decrease the exponent by 1, so just x to the first, that's just x. That's being multiplied by x plus 1. And then we're also subtracting x squared times the derivative of x plus 1. Let's break that up. Derivative of x is just 1, so we've got 1. And then derivative of 1, derivative of a constant, is just 0. So 1 plus 0, just 1. And then that's all over x plus 1 squared. Alright, let's just expand out the numerator, see if some things cancel. So 2x times x, that's 2x squared. And then 2x times 1, so plus 2x. And then minus x squared times 1, so just minus x squared. And that's all over x plus 1, the quantity squared. We can simplify the numerator a bit. 2x squared minus x squared is just x squared. So x squared plus 2x over x plus 1 squared. And why don't we just go ahead and factor the numerator so it's nice and clean. We do a lot of things with the derivative that involve using its factored form, so go ahead and factor it. We can pull out an x from both of these terms in the numerator, so x times x plus 2, those are the remaining bits left over after pulling out the x. Now that's all over x plus 1 squared. So there we go. That is the derivative of that rational function. Alright, on to the next function. Given y equals e to the x over x plus sine x, compute dy dx. So really we're just taking the derivative again. This time the numerator is e to the x, and the denominator is x plus sine x. So we just go ahead and set up that quotient rule. In the numerator, we start out by taking the derivative of the numerator, e to the x, and multiplying by the denominator, x plus sine x. And then we subtract the product of the numerator, e to the x, and the derivative of the denominator, which is x plus sine x. Now that's all over the denominator, x plus sine x squared. So we'll go ahead and compute this. Draw that fraction bar. Look in the numerator. The derivative of e to the x, well, that's still just e to the x. E to the x stays itself after differentiation. So e to the x times x plus sine x, and then minus e to the x times the derivative of x plus sine x. Derivative of x is just 1, and then derivative of sine x is just cos x. And that's all over x plus sine x squared. Now let's try to factor the numerator as much as we can. We see there's an e to the x in both of the terms here, so we'll just go ahead and pull out an e to the x, and then it's multiplying all these terms. So we have an x, then a plus sine x, and then if we distribute that minus sign over the other two terms, we get a minus 1, then minus cosine of x. And that's all over x plus sine x squared. It doesn't look like there's anything else we can simplify, so I guess we're done. That is the derivative of our function y is e to the x over x plus sine x. The takeaway from this example in particular is that the quotient rule can get kind of messy sometimes. And that's just the way it is. So if you get a really messy expression after applying the quotient rule, it doesn't necessarily mean you've done anything wrong, because that might be the simplest it can get. Here's our next problem. We're given this function f of x equals 3 times natural log of x over x, and we want to compute the slope of the tangent line to the graph of y equals f of x at the point x equals e. Now, slope of the tangent line, well, that's just the derivative. So we want to evaluate the derivative at the point x equals e. That just means we want to compute f prime of e. Compute the derivative of f and evaluate it at e. But in order to do that, we need to compute the derivative, the general derivative, f prime of x, because we need to plug in e for x afterwards. So that means we're going to have to take the derivative of that fraction, which has the numerator 3 natural log of x and the denominator x. So because this is a fraction, we apply the quotient rule, and the quotient rule goes like this. The result is a fraction, and we start out by differentiating the numerator. To differentiate 3 times natural log of x, we multiply that result by x, and then subtract where the derivative is switched. So this time, instead of differentiating the numerator, we just leave the numerator alone, but we differentiate the denominator, which is just x. And now it's all over the original denominator squared, so all over x squared. Now let's go ahead and compute these easier derivatives. We've still got our fraction. We're looking in the numerator first. The derivative of 3 times natural log of x. Well, remember, constants factor out of the derivative, so we just have 3 times the derivative of natural log, and derivative of natural log is just 1 over x. So 3 times 1 over x times x. And then minus 3 natural log of x times the derivative of x, which is just 1, all over x squared. Let's keep on simplifying before we plug in for x, just to save a bit of work. So first of all, we notice that this 1 over x times x, this cancels in the numerator. And we also notice that we can pull out a 3 from both of these terms in the numerator. So let's go ahead and pull out that 3. 3 times, what are the leftovers? Well, this term just simplified to 3, so we just have the leftover of 1. 3 times 1 makes 3. And then minus, this term was 3 times the natural log of x times 1, so really just 3 natural log of x. So when we factor out the 3, what's left over is natural log of x. And then that's all over x squared. So now it's time to go ahead and substitute e wherever x is. We'll go ahead and compute the derivative evaluated at e. So let's go ahead and write that down. So that's 3 times 1 minus natural log of e, and that divided by e squared. And what does this simplify to? Well, let's just go ahead and write it down, simplify what we can. First of all, natural log of e, that's just 1, because e raised to the first power is e. So 3 times 1 minus 1 all over e squared. And 1 minus 1 is just 0. So we have 3 times 0 over e squared. So this is really just 0 over e squared, which is just 0. So that is the slope of the tangent line to the graph of y equals f of x at the point E. It's just a horizontal flat tangent line, slope is 0. So now we know how to use the quotient rule to differentiate fractions. And in the future, we'll learn how to use this quotient rule to differentiate the reciprocal trigonometric functions.